Hi everybody, it's me again, and tonight I'm going to be rabbiting on about the laser interferometer system again. And tonight I want to talk about optics, because what arrived in the post today are these little polarising beam splitters, or otherwise known as linear interferometers. So I've got two of these, and I've got some little plane mirror converter windows, which we probably won't need, but we've also got these snazzy little internal cube mirrors. So they're called retroreflectors, and they are a special kind of mirror that is a prism that's cut from a cube and then turned around, polished on each face, and it's coated on the outside and then put in this little mount. And the reason these are used is so that you get a parallel beam. Whatever comes in comes out parallel. So I've just hot melt glued that to this block of aluminium, and I've set that up on here on what is without doubt the world's dodgiest laser interferometer measurement test rig, and it consists of a couple of bits of board and a steel rule hot melt glued onto here, and I've got this sitting ironically enough on a Myford pulley. And set up, so if you can't quite see it from over there, but you'll take my word for it that this is all set up so that the beam that's coming out of the laser is actually being reflected internally through the retroreflector back to the photodetector that's in the laser head. And if you can see it there, it's actually pointing right on that target. And I don't want to move the camera or move anything else, but that's where it's going, back into the laser head. And then half of the beam comes through the polarising beam splitter out to the retroreflector and gets sent back to the same spot. So if I move this a little bit, you can actually see that beam moving around. So for our purposes, we want that to stay all nicely lined up, which it is there. So I've got this little bit of wood here, this steel rule, which will give me a pretty coarse measurement, but at least give me a guide as to how far this is moving. So the way this is set up is it's set up to only measure linear measurement. At the moment all it'll do is measure displacement. If we want to measure flatness, we need to arrange two of these retroreflectors vertically above one another, and we need to put a 45-degree mirror here, and we'll get to that later on. But at this stage what we want to do is to get our beam alignment right. So we open the window to the photodetector. Our beam alignment's way over in the green. We hit the reset. Unfortunately the lamp's gone, I think, in the reset. It should be flashing when we don't have beam alignment, but at the moment that's just stopped working for some reason. But it's no big deal. We've got this in smooth mode. If we put it in the normal mode, we can see this jittering around quite a lot. So the smoothing is a mathematical smoothing of it that actually smooths it out so that the display stays quite stable. And here we are, it's stable to within, that's 1,000th of a mil, that's a micron. So this is stable to within 1/10 of a micron. And you can see me just leaning on the table there. It's causing that to move about quite considerably. So we just reset that. I've got that lined up with the 200mm mark there. And now I'm just going to move it towards the laser head by 50mm off the ruler. And we'll see what the display does. So we take it 50mm, and we're up to 49.75 over there. Let's go another 50mm, and it should be somewhere around 100. 99.8. Let's move it another 50, and we've got it should be somewhere around 150. There we are, 149.8mm. Let's move it all the way back to the -50 positions about here. Okay, well it's +50 because it's gone opposite sense, but we can actually just change that here with the direction sense switch. So there it is at 50.16. So you know I can move this to within 1/10 quite easily. So what we've created here is effectively super high precision digital readout, and that's all they were used for. Most of these systems ended up on machining centres, and these were used as XY positioners for super high precision positioning of the table in the manufacture of integrated circuits where they use what's called nanolithography, photography at nanometer scales to produce the little circuits that are on integrated circuit chips. So if we move this backwards and forwards, I could do this all day, this is bloody wonderful. So you see we've got a 0, close enough to 0 there. Take it up to about 50, there we are, 50.3, up to about 100, yeah, back to 75. There you go, it works like a beaut. Couldn't be happier. Okay, any questions about any of that, just send me a message. But we're on to the next bit now, which is to design a little block to support these two in the right configuration. But we'll probably design the mirror first so that we can then get the actual correct spacing of these, because the two retroreflectors, this one has to be mounted above this one in pretty well perfect alignment with the mirror. The downside of using these later model 1.5" cubes with this older system is that these optics were designed for a system which has a photo detector in a separate box, and they were designed to be put onto machine tools. So as these systems evolved, although the internals do exactly the same thing optically, the physical arrangement of them got a lot smaller. So whilst the windows and things on these are big enough to do the job, the beam benders that came with this series of interferometers, that is the 1.5" cube beam benders, were in fact only designed for single beams, and you need them to be able to accommodate the two beams, because you've got a forward beam coming out of here and a return beam there. Oh, there's our reset light has come back on. So weird. I don't know why we're getting erratic operation of the reset. So that's not the lamp. That's something else that I'll have to investigate, but we'll get to that. So the next thing is to work out how to mount a mirror there at 45 degrees, because we can't just go out and buy one. We can buy a flat mirror similar to the flat front face aluminium mirror there, but we can't buy one mounted up ready to go inside a cube that'll bolt nicely onto the top of there, because they simply didn't make one for this series of interferometer optics, unfortunately. Alright, so I'll put a couple of links in the description below to the PDF, where you can see all the drawings and diagrams of these things. If anybody's interested in seeing how it all fits together. There's quite a bit in it, and it took quite a few hours of digging to find what would work with what, because there were lots and lots of different variations by Hewlett-Packard over the years as these systems evolved. But yeah, I'm like a kid with a new toy. This is really, really fantastic to see this counting backwards and forwards, up and down, stable and precise and repeatable. I think everything's working just the way it should. With not a lot of effort now, we'll be able to adapt this to flatness measurements, so we can calibrate our surface plates when they arrive. Maybe not the week they arrive, but after we make the parts and things, we'll be able to confirm their actual calibration specifications. So thanks for watching, and see you next time. Next time will be part 6. This is part 5. So bye.